A B-24 Liberator rolls off the assembly line, Willow Run, Michigan, every 63 minutes, December 1944. Ford's sprawling factory floor stretches further than the eye can see. What once seemed impossible has become routine. This is the story of how American industry built 100,000 aircraft in a single year and changed the course of human history. March 15, 1942, Willow Run, Michigan. Charles Sorensen stood in an empty field, blueprints trembling in his hands. Ford's production chief had built the Model T assembly line. He'd revolutionized automobile manufacturing. But this was madness. The telegram from Washington sat folded in his pocket. Build 1 bomber per hour, every day. His fingers traced the blueprint dimensions. Length, 3,500 feet. Width, 1,280 feet. The largest room under one roof in human history. And they wanted it operational in 6 months. It can't be done, his assistant said. Sorensen didn't answer. He was counting. 18,000 workers. 400 railroad cars of materials daily. A mile-long assembly line. Parts arriving from 12 states. The math shouldn't work. But Henry Ford had already signed the contract. From cars to combat. 6 months earlier, America had 2,000 military aircraft. Germany had 5,000. Japan had 3,000. The arithmetic of war was brutal and simple. Whoever controlled the skies controlled the battlefield. Roosevelt knew it. Hitler knew it. Every general on both sides knew it. The difference was production capacity. In 1941, American factories built 4.7 million automobiles. They manufactured 120 million tons of steel. They employed 15 million industrial workers, all of it civilian, all of it peacetime. Pearl Harbor changed everything. Within 72 hours, Chevrolet halted car production. Packard stopped making luxury sedans. Studebaker, Nash, Hudson, every automaker in America received the same directive: convert to aircraft manufacturing, immediately. Nobody knew if it would work. William Knudsen, former General Motors president, coordinated the transition. He'd built GM into an industrial empire. Now he stood in a Detroit boardroom, staring at factory floor plans, trying to imagine machine tools that cut steel for Buicks instead, cutting aluminum for B-17s. The tolerance specifications are different, an engineer explained. Aircraft parts require precision within thousandths of an inch. Car parts... I can read the specs, Knudsen interrupted. How long to retool? 6 months, maybe 8. You have 6 weeks. The engineer's face went pale. Find a way, Knudsen said. The women who built wings. June 1942, Douglas Aircraft, Long Beach, California. Rose Monroe had never touched an aircraft before. She'd been a waitress, a mother, a widow after her husband died 2 years prior. Now she stood on a factory floor the size of 10 football fields, holding a rivet gun that weighed 15 pounds. Keep it steady, the supervisor said. 3 rivets per minute, 8-hour shifts, 6 days a week. Rose squeezed the trigger. The pneumatic hammer drove the rivet home with a sound like a gunshot. Metal met metal, precise, permanent. She'd done one. She needed to do 17,000 more by the end of her shift. Around her, 2,000 women worked identical stations. Most had never held industrial tools before. Teachers, secretaries, store clerks, housewives, all of them learning to build P-38 fighters because the men were overseas fighting. The supervising engineer walked the line, checking tolerances with calipers. 0.5 millimeter off, he told one worker. Redo it. Rose watched the woman remove the rivet, drill it out, start again. No complaints, no arguments, just precision. By August, the Long Beach plant employed 14,000 women. They worked swing shifts, day, evening, night, keeping the assembly lines running 24 hours. The factory never stopped, never slowed. Production targets seemed impossible. 300 aircraft per month. They hit 350. And if that surprised you as much as it surprised the military planners who thought women couldn't handle industrial work, hit that like button. These stories need to be told. Now, Back to the miracle. The genius of mass production. The traditional method of building aircraft required 18 months. Skilled craftsmen assembled each plane individually, every component custom fitted, every system hand tested. America didn't have 18 months. They needed a different approach. Henry Kaiser provided it. The shipbuilder had revolutionized Liberty ship production by breaking construction into prefabricated sections. Build the pieces separately, assemble them together, cut production time by 2/3. Boeing applied the same principle to the B-17 Flying Fortress. Traditional construction, 45,000 man-hours per aircraft. Kaiser method, 18,000 man-hours per aircraft. The shift required reimagining everything. August 1942, Boeing Plant 2, Seattle. Engineers stood around a disassembled B-17, components spread across the factory floor like a massive puzzle. Wings, fuselage sections, tail assembly, engines, 40,000 individual parts. "We need to make them interchangeable," the lead engineer said. This was the revolution, standardization at unprecedented scale. Every B-17 built in Seattle had to accept wings built in Long Beach, tail assemblies from Tulsa, engines from Chicago. The parts had to fit perfectly, despite being manufactured in different factories, by different workers, with different equipment. The tolerance specifications were insane, plus or minus 0.5 inches across components weighing thousands of pounds. It required new quality control systems, new measurement tools, new training protocols. And it worked. By October 1942, Boeing received fuselage sections from Lockheed, married them to wings from Douglas, installed engines from Pratt & Whitney. The B-17s flew identical to factory original specifications. The assembly line moved continuously, one aircraft every 90 minutes. The logistics nightmare building. The aircraft was half the challenge. Supplying the materials was the other half. Each B-17 required 13,600 pounds of aluminum, 2,880 pounds of steel, 100 pounds of copper, 462 pounds of rubber, 17 miles of wiring, 360,000 rivets. Multiply that by 100,000 aircraft. The numbers became incomprehensible. 1.36 billion pounds of aluminum, 288 million pounds of steel. America's entire mining industry shifted to military production. Bauxite from Arkansas, copper from Arizona, steel from Pennsylvania, rubber plantations in Brazil, Liberia, Ceylon, all feeding the production machine. The railroad system strained under unprecedented loads. November 1942, railway switching yard, Chicago. Freight cars stretched to the horizon, each one labeled Priority War Materials, aluminum sheets from Alcoa, steel plates from U.S. Steel, engine blocks from Pratt & Whitney. The yard supervisor tracked movements on a massive board. Hundreds of trains, thousands of destinations, all coordinated to the minute. Factory 241 needs aluminum, a dispatcher called. They're running short. Reroute the Cleveland shipment, the supervisor replied. Get it there by 0600. 12 hours later, the aluminum arrived. The assembly line never stopped. This coordination across 48 states, thousands of suppliers, millions of workers, represented organizational complexity never before attempted, and somehow it functioned. The speed increases, January 1943, Consolidated Aircraft, San Diego. The B-24 Liberator production line moved like a mechanical heartbeat, steady, relentless. Chassis, 22 minutes, wing assembly, 31 minutes, engine installation, 18 minutes. Final systems, 45 minutes. Total time, wheels to wheels, 116 minutes. But Ford's Willow Run plant had different ideas. Charles Sorensen walked the mile-long assembly line he'd built in that empty Michigan field. The massive building now housed 42,000 workers operating across 3 shifts. The conveyor system moved continuously, carrying partially assembled bombers through 96 workstations. "We can go faster," Sorensen said. His engineers looked skeptical. "Current rate is 90 minutes per aircraft," one replied. "That's already at 63 minutes, Sorensen interrupted. "That's the target." They modified the workflow, redesigned tool placement, adjusted worker positions by inches to reduce motion waste, applied automotive production principles to 4-engine bombers weighing 36,000 pounds. By March 1943, Willow Run achieved it, one B-24 every 63 minutes. The military observers couldn't believe it. They watched bombers roll off the line, massive, complex, combat-ready aircraft, faster than most factories could build cars. Jabir, the quality question speed meant nothing if the aircraft failed. Every plane underwent rigorous testing, ground tests, engine tests, flight tests, stress tests, combat simulation. April 1943, Boeing Test Facility, Washington. Test pilot Eddie Allen climbed into a brand new B-17, fresh off the Seattle line, serial number 4229477, built in 17 days from raw materials to completed aircraft. "Systems check," Allen said into the radio. "All green," the ground crew replied. Allen advanced the throttles. 4 Wright R-1820 engines roared to life. The bomber accelerated down the runway, 65,000 pounds of aluminum and steel defying gravity. Altitude, 5,000 feet, 10,000, 15,000. Allen put the aircraft through combat maneuvers, sharp banks, sudden climbs, simulated evasive action, maximum stress conditions. Every rivet held, every system functioned, every specification met. "She flies perfect," Allen reported. That aircraft, built by workers who'd never manufactured planes before, using mass production techniques considered impossible 2 years earlier, performed identically to pre-war custom-built models. And this wasn't exceptional, this was standard. Quality control rejected less than 3% of aircraft, a failure rate lower than peacetime production. Roberts, the numbers mount, December 1943, War Production Board, Washington, D.C. Donald Nelson studied the production reports with growing disbelief. January 1942, 100 aircraft produced. January 1943, 5,200 aircraft produced. The growth curve wasn't linear, it was exponential. February 5 to 800, March 6,100, April 6,400. By summer 1943, American factories produced more aircraft in 1 month than they'd produced in all of 1939. The military couldn't absorb them fast enough. "We have 2,000 P-47s sitting in storage," an Air Force logistics officer reported. "No pilots to fly them." "Keep building," Nelson replied. Because the strategic calculation had shifted, America wasn't just equipping its own forces. Under Lend-Lease, they were supplying Britain, Soviet Russia, China, Free France, every allied nation. Soviet pilots flew American P-39 Airacobras. British bombers included American B-24s. Chinese forces received P-40 Warhawks. The aircraft flowed outward like an industrial flood. 14,000 planes to Britain, 18,000 to Russia, 1,300 to China, and America still had enough for itself. The workforce transformation. The miracle wasn't just mechanical, it was human. March 1944, Kaiser Shipyard, Richmond, California. Margaret Kincaid riveted aircraft sub-assemblies. 2 years ago, she'd been a school teacher in Iowa. Now she operated precision tools, read engineering blueprints, performed quality inspections that determined whether pilots lived or died. She wasn't alone. Across America, 6 million women entered the industrial workforce. They learned machining, welding, electrical systems, hydraulics. They mastered skills traditionally considered men's work in months, not years. The propaganda posters called them Rosie the Riveter. The factory supervisors called them essential. Production data proved both right. Plants employing women achieved quality standards equal to or exceeding all-male facilities. The idea that women couldn't handle industrial work, a notion taken as fact before the war, died under the weight of evidence. Productivity per worker increased 25% between 1942 and 1944. Not because individuals worked harder, but because training improved, processes streamlined, and talent previously excluded entered the workforce. African Americans faced their own barriers. Many factories refused to hire black workers despite desperate labor shortages. Executive Order 8802 mandated non-discrimination in defense industries. Progress came slowly, grudgingly, but it came. By 1944, 2 million African Americans worked in war industries. They operated the same machines, built the same aircraft, met the same standards as white workers. The industrial necessity of war accelerated social changes that peacetime politics had resisted for decades. Peak production, 1944, the year of maximum output. The numbers stopped seeming real. January 7,900 aircraft, February 8,100, March 8,400. American factories now produced more aircraft than Germany, Japan, Italy, and their remaining allies combined. The comparison became absurd. 1944, U.S. production, 96,218 aircraft. 1944, German production, 39,807 aircraft. 1944, Japanese production, 28,180 aircraft. America alone outproduced the entire Axis by nearly 2 to 1, and the gap kept widening. By June 1944, D-Day, American and British forces achieved total air superiority over Europe. German fighters couldn't contest Allied bombers. They simply lacked the numbers. Luftwaffe pilot Franz Stigler, in a post-war interview, described the experience. "We would shoot down 10 of their bombers. 20 would replace them the next day. We lost 2 fighters. We got 1 replacement. The mathematics were impossible." The Pacific Theater told the same story. Japanese aircraft production peaked at 2,572 planes per month in July 1944. American production that same month, 9,113 aircraft. Wave after wave of American fighters, bombers, transports, reconnaissance aircraft overwhelmed Axis air forces through sheer numerical superiority. The human cost of speed. But the miracle had a price. July 1944, Willow Run Plant, Michigan. The accident report documented what everyone already knew: fatigue kills. A worker 63 hours into a 72-hour week misjudged a clearance. His hand entered the path of a hydraulic press. The machine didn't care, didn't stop. 4 fingers severed in an instant. Industrial accidents increased with production speed. Workers pushed to exhaustion. Safety protocols abbreviated to meet quotas. Injuries mounted, crushed hands, severed limbs, chemical burns, falls from scaffolding. The official statistics recorded 37,000 serious injuries in aircraft plants during 1943-1944. The actual number, including unreported incidents, likely doubled that. Rose Monroe, the riveter who'd started at Douglas in 1942, watched co-workers carried off the factory floor on stretchers. She watched new workers arrive the next day to fill their positions. The production line never stopped. "Is it worth it?" a young assembler asked her once. Rose thought of her husband killed at Pearl Harbor. She thought of the bomber crews flying planes she'd built. She thought of the alternative, losing the war. "Yes," she said, and returned to her rivet gun. The strategic impact military planners had understood air power's importance. What they hadn't understood was industrial capacity's revolutionary potential. December 1944, 8th Air Force Headquarters, England. General Curtis LeMay studied loss reports with satisfaction. Not because losses had decreased, they hadn't. The Luftwaffe still shot down American bombers with brutal efficiency, but replacement rates exceeded losses by factors of 10. "We lost 43 aircraft yesterday," an aide reported. "How many replacements?" LeMay asked. 217 arrived this morning." This was the new arithmetic of war. Accept losses that would have been catastrophic in 1942 because American production could absorb them. Send wave after wave of bombers, 1,000-plane raids, knowing that losses were tactically irrelevant when you could replace them overnight. The strategy was brutal, wasteful, and devastatingly effective. German cities burned under incendiary raids. Japanese industrial centers collapsed under precision bombing. Infrastructure, factories, refineries, railways, all targeted, all destroyed, all because American aircraft filled the skies in numbers Axis forces couldn't match. The bombing campaign's moral questions persist to this day, but their strategic impact was undeniable. They crippled Axis production capacity, while American production accelerated. If this story of industrial transformation has opened your eyes to how World War II was truly won, Subscribe so you don't miss the next forgotten chapter of history that changed everything. The conclusion ahead will show you the final numbers. The final tally, May 8, 1945, VI Day. The war in Europe ended. Production didn't. Factories continued building aircraft for the Pacific Campaign. The numbers kept climbing. August 14, 1945, VJ Day. Japan surrendered. Finally, the production line stopped. The accountants tallied the final numbers. Total U.S. Aircraft production 1940, 1945, 1940, 2,141 aircraft, 1941, 433 aircraft, 1942, 47 of 836 aircraft, 1943, 85 of 198 aircraft, 1944, 96,018 aircraft, 1945, 46 out 1 aircraft, partial year, grand total 296,127 aircraft in 5 years. The types varied: fighters, bombers, transports, trainers, reconnaissance, and seaplanes. But each one represented the same industrial miracle, the transformation of civilian manufacturing into military production at a scale history had never witnessed. For context, Germany produced 119 to 307 aircraft during the entire war. Japan produced 76,320. Italy produced 11,122. The United States outproduced all 3 Axis powers, combined by a factor of 2.5. The Verge, the Aftermath, and September 1945, Willow Run Plant, Michigan. Charles Sorensen walked the empty assembly line one final time. Silent machines stretched into darkness. The mile-long conveyor system, motionless for the first time in 3 years. No workers, no aircraft, no urgency. The building, largest room under one roof in the world, already felt like a cathedral to a dead god. The god of war production. "What happens to it?" an assistant asked. Sorensen didn't know. Nobody knew. How do you convert capacity built for producing 18,000 bombers back to peacetime? The answer, you don't. Most war production facilities closed. The massive investments, billions in equipment, training, infrastructure, became economically worthless overnight. Willow Run itself eventually became a commercial center, then stood vacant, then faced demolition. The workers dispersed. 6 million women left industrial jobs. Some by choice. Many forced out by returning servicemen, reclaiming their positions. The skills they developed, machining, welding, engineering, often went unused as peacetime society pushed them back into traditional roles. The social transformations the war had accelerated didn't vanish, but they paused. Civil rights progress slowed. Women's workforce participation declined. The industrial opportunities that had opened during crisis closed during peace. Rose Monroe returned to waitressing, her precision riveting skills, capable of holding together aircraft under combat stress, found no peacetime application. She never forgot, though. In interviews decades later, she described the factory work with pride. "We built something that mattered, something that lasted." The legacy. The aircraft themselves, those 297,627 planes built between 1940 and 1945, had varied fates. Some served through decades of Cold War. The B-29 Superfortress remained in active service until 1960. Some transports and trainers lasted even longer. Most were scrapped. Aluminum salvaged and melted down. Military surplus sold for pennies on the dollar. By 1950, fewer than 5,000 wartime aircraft remained in U.S. service. But the industrial knowledge endured. The mass production techniques developed for aircraft manufacturing influenced post-war industries: automobiles, electronics, construction. The quality control systems, standardization protocols, supply chain management, all transferred to civilian applications. The organizational lessons proved equally durable. The coordination required to build 100,000 aircraft annually, synchronizing materials from thousands of suppliers, training millions of workers, maintaining quality at unprecedented scale, demonstrated capacity for planned industrial mobilization that shaped Cold War defense policy. And the human lesson that remains most profound. Reflections, 20-24, Museum of Flight, Seattle. A B-17 sits on display, polished aluminum gleaming under museum lights. Serial number 4485784. Built at Douglas Plant, Long Beach, April 1945. Visitors walk around it, taking photos, reading plaques. They see the machine, the engines, the wings, the gun positions. They don't see the invisible infrastructure, the teenage girl from Oklahoma who riveted the tail section, the mining engineer in Arizona who extracted the copper, the railroad dispatcher who coordinated aluminum shipments, the factory supervisor who worked 100-hour weeks, the test pilot who certified flight worthiness. Thousands of invisible hands built every aircraft. The placard mentions production statistics. U.S. factories produced 297,627 aircraft during World War II. But statistics miss the human transformation. The waitress who became a precision machinist, the engineer who reimagined mass production, the logistics coordinator who synchronized continental-scale supply chains. They built more than aircraft. They built proof of concept that free societies could mobilize industrial capacity faster and more efficiently than authoritarian ones. That inclusion of women, minorities, previously excluded talent strengthened rather than weakened production. The lesson echoed through subsequent decades. When America needed to reach the moon, build an interstate highway system, develop computing infrastructure, the organizational templates traced back to those war production years. The miracle wasn't just the 100,000 aircraft in 1944. The miracle was discovering that such production was possible at all. The Woman and the Rivet, a 1987 Veterans Day ceremony, Long Beach. Rose Monroe, 73 years old, stood before the restored P-38 fighter, the same model she'd assembled 45 years earlier. A reporter asked the inevitable question, "What do you remember most?" Rose touched the fuselage, fingers finding rivet lines invisible to untrained eyes. "The sound," she said, "that pneumatic hammer. Bang, 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 18,000 times per shift. I heard it in my sleep." Was it worth it? Rose studied the aircraft, combat veteran of the Pacific Theater. 53 missions, 14 confirmed kills. Pilot survived the war, became a commercial airline captain, raised 3 kids. Every rivet held, Rose said. That was the answer. Every rivet held. Under combat stress, under enemy fire, under conditions the designers barely imagined, the aircraft held together because workers cared enough to get each rivet perfect. 18,000 rivets per shift. 42,000 workers at that plant alone. 6 million women nationwide. 5 years of production. Every rivet held. The true measure. The ultimate measurement isn't aircraft produced, it's capacity revealed. Before 1940, nobody knew if democratic societies could mobilize for total war. The question hung over every strategic calculation. Could free peoples, accustomed to individual liberty and market economics, coordinate national effort effectively? The authoritarian powers, Nazi Germany, Imperial Japan, Fascist Italy, bet they couldn't. Their entire strategic theory depended on quick victory before American industrial potential materialized. They lost that bet. American aircraft production proved that democratic societies could organize, mobilize, and outproduce authoritarian ones, not through force or coercion, but through coordination, innovation, and the unleashing of previously constrained talent. The women entering factories, the minorities gaining industrial skills, the engineers solving impossible problems, the workers maintaining quality under impossible pressure, all volunteers, all choosing participation, all making the industrial miracle possible. That's the story the statistics conceal. 297,627 aircraft, but underneath, millions of individual choices, millions of small contributions, millions of ordinary people achieving extraordinary results. The Sutter conclusion, today. When we speak of American industrial might, we're often referencing an abstraction, a vague notion of factories and production capacity. But the 1940-1945 aircraft production miracle wasn't abstract. It was concrete, specific, measurable. It was the waitress learning to rivet within thousandths of inch tolerances. It was the engineer discovering that automotive mass production principles could build bombers. It was the logistics coordinator synchronizing materials across continental distances. It was the test pilot trusting that assembly line aircraft would fly as reliably as custom-built ones. It was all of them, together, building proof that impossible production targets could become routine. 100,000 aircraft in a single year. The number seemed impossible in 1940. By 1944, it was reality. That transformation from impossible to routine represents the true miracle, not the machines, but the human capacity to reimagine limits, reorganize systems, and achieve what previous generations considered fantasy. The aircraft are gone now, scrapped, salvaged, scattered to museums. But the lesson endures. We contain more capacity than we typically access, more potential than we usually demand, more capability than we routinely demonstrate. Sometimes under pressure, facing impossible odds, with everything at stake, we discover what we're actually capable of achieving. 100,000 aircraft, 1 year, 1 people, 1 miracle. The numbers tell part of the story. The human transformation behind those numbers, the workers, engineers, coordinators, and leaders who made the impossible routine. That's the story worth remembering.